So today we are having Tania Allard with us for our third keynote. So for those of you who do not know Tania and you were there at the AGM yesterday, she was at the very top of the list of all the trustees. She has been in the committee for quite some time now, and we're very happy to have her. So now she's the CEO of Impact at Quantsite. She leads effort to sustain and grow critical open source scientific computing projects. She's a renowned advocate for open science, open source, and ethical AI. And she has an extensive experience in research software engineering, data science, and community building. With expertise between spanning industry leadership and academic roles, she bridges the gap between industry and open source. And she's driven by a passion for education, collaboration, and inclusivity. And now I'm going to put your slides on.
Okay, there we go. Can everyone hear me over there? Great. Well, so that was an introduction, and today I'm here to talk about how to keep research software relevant for tomorrow. It was very fortuitous because I missed Simon's talk and I missed Amanda's talk. I saw the highlights. And it's just pure coincidence that it seems like some of the topics that I'm going to be talking about today kind of weave this too. So interesting stuff. That is me. If you see something different, yes, my hair is less purple, but I wear a lot of hats. My day-to-day hat is the CEO of Impact, so that's a lot of stuff. Apart from that, I have my fingers in a lot of open source projects, open source communities. I am part of the Python Software Foundation Board of Directors and Advisory Committee for New Focus now in certain capacity. If you need to access my slides for accessibility purposes, you can scan that code and follow along as well. So Quantsite is not a big company, and whenever I say I work at Quantsite, this is the first question I get asked. What do you do? The sanitized version is I work towards making critical open source software and infrastructure sustainable. That means that the ecosystem is sustainable, the maintainers thrive, the community thrive, and making sure that everything is accessible, robust, and secure for the long term. What that means in practical terms is managing stakeholders a lot, drawing a lot of strategy, and herding a lot of cats. Herding cats every day. But I've highlighted two words there, and the most important word there is sustainability. It's very, very hard to describe sometimes what sustainability means. But there is this definition from the Puntland report that I really, really like. And it says, it defines sustainable development as development that meets the needs of the present without compromising the ability of future generations to meet their needs. And when I talk about future generations in the context of open source software or research software, I talk about future generation of users, researchers, developers, contributors, maintainers, all of these people that use and engage with open source or research software in any capacity. Getting to that point of sustainability where you have an ecosystem thriving while making sure that the next generation to come is going to have a better ecosystem is a very tricky balancing act. Because a very, very big part of these stakeholders or these communities are companies, are industries, are corporations. And just to put things in context, there are numbers around saying that about 90% of these companies use or rely on open source to an extent. Open source has seen massive, massive growth in the last couple of decades, really. But despite that growth and despite that success and despite being in 90% of the companies and up to 97% of applications worldwide, the ecosystem is not as healthy as it could be. Because these companies and corporations using open source are not supporting it enough. Again, if we go to numbers, this is very, very hard to quantify. But we can say that up to 30% of those companies are supporting open source in a way, right? And we have a big, big gap of 70% of companies that are not. Now, if you like numbers again, there is this report from 2024 from the from Harvard Economics, sorry, that estimates that the market value of open source is about $8 trillion a year. Right? So it's a big, big gap. 70% of that figure is massive, and it's still inaccurate because there is not one single first order of magnitude metric that we can use to actually quantify the value and the cost of open source out in the world. But just that number is huge, it's massive, right? But okay, this is open source, we're in research software engineering. What does this have to do with research software? Has to do a lot, because historically, research software engineers and researchers have been a critical and foundational part of our open source ecosystem. I work a lot in what probably many of you are familiar with is the PyData ecosystem. This is a very, very, very outdated graphic of this ecosystem. It's so much bigger now. It has like so many layers, sub-communities, sub-ecosystems. But many of the folks that started working on this project, say SciPy, NumPy, for example, that are the foundational ones, started as RSCs or started as researchers. They had a need, they had to scratch an itch, and just started hacking away and created NumPy or SciPy as part of their PhD theses or their postdoc work. Many of these people are still around the community, but have since left academia for multiple reasons. There are many, many reasons. But for many of us, me included, being part of this research software engineering community meant that we had dedicated time and capacity to engage with and participate in open source. Yesterday, when I saw the highlights of Simon's talk, I saw a picture of the very, very first RSC committee. Mike was there, Simon was there, Rob Haynes was there, Claire was there, I was there, and that felt almost like a lifetime ago. It's actually a whole lifetime ago. But it was just because I had that dedicated time and support and mentorship and sponsorship from all of these folks around me that I was able to participate in open source, that I was able to establish my career and find something that I am very passionate about. And 10 years later, it's still what I am doing, but I am more on the strategy side than I was at the hands-on and side of things. I still do all of it. But that pathway was critical for me, as for many others. And even though RSCs and researchers are a foundational and critical part of the open source ecosystem, I sometimes have spoken to RSCs that are still in academia, and they say, oh, well, I really don't feel like I'm part of the open source community. And I think a lot of this is part of how incentives are still misplaced in academia and research environments. A lot of things have changed in this history of the RSC community in the formalization of the role itself, but there are many other things that have been very, very slow to catch up. But cultural and systemic change is incredibly slow. It's incredibly hard to achieve. And to this day, grants and funding mechanisms still favor short-term innovation versus long-term maintenance. And I think that is something that contributes massively to our perceptions of we are research software engineers, we are not part of the open source community. We've seen a lot of projects, like I'm sure many of you have seen projects that are a brilliant PhD thesis or a brilliant piece of software coming out of a research project or grant. But as soon as that funding ends, or as soon as that PhD program ends, and then 2 years go by, then that piece of software is obsolete, unmaintained, and basically it's just rotting somewhere. Because there is no foundational support or funding or capacity to keep that alive. And that is the paradox that we are consistently fighting with. How do we build and develop impactful software when we don't know what our capacity is going to be in 2, 3, 5 years' time to keep it alive? And again, it's not just academic institutions and research institutions. It's again, in corporate environments, incentives are misplaced because what we recognize, what we acknowledge, what we measure and how we measure it and how we incentivize matters. Sometimes we say in an organization or in an environment, say, well, we really care about openness and we really care about open source software and we care about innovation. But really, what you measure, what you highlight, and what you fund are your real priorities. If you're not putting literally your money where your mouth is, it's just lip service. And that has been happening still a lot of the time. And again, this is like part of that cultural change that has been very slow to happen. Because OSPOs, or open source program offices, are still very rare in academia, despite RSCs being foundational to open source. And the formalization of the RSC role has taken forever, but the culture overall has been very, very slow to catch up to the realities of this role. So it's very easy to get distracted, right? If you follow the news and see these highlights, then you would think, oh, open source Python is thriving. Everyone is using Python. So surely the Python Software Foundation gets a lot of money and a lot of support because it's everywhere, right? It's the most popular language for Gen AI. It's the most popular language for research and data analysis. But also, all the spotlights are on these things now, like Gen AI, AI-supported assistants and apps. And the spotlight is actually going where the money already is. Where is this capital to then develop all of these applications and all the uncertainty that is bringing to other parts or other ecosystems that are already under-resourced or overstretched? And it brings a lot of concerns. I saw also there was in the program something about RCs versus or RCs and Gen AI, because it's a reality. Gen AI is permeating every single aspect of the software industry. It's everywhere. It feels like it's just being pushed into every app and tool that you're using in one way or another. So in these days where the concerns and the headlines and the news are all about AI is going to replace, insert whichever role it is. My tip to you is do not confuse raising the floor with raising the ceiling. Sorry, I run out of breath these days. And this is very important. Right? Like, don't confuse raising the floor with raising the ceiling, because you want to be at the place, especially as a research software engineer is someone pushing innovation and research. You want to be at a place where you're pushing the ceiling. And what does it look like in these days? Really, the floor, when we think about all of these Gen AI-powered applications, the floor are those applications that commoditize tasks that have been in the industry for a very, very long time, right? That's why they're easy to automate. That's why they're easy to replace, because the tasks are the same. The only thing that has changed is the scale. If you think about text classification, summarization, paraphrasing, those are tasks that have been around for decades. The difference, again, is the scale. The scales of people that need to do that, the scale of data that we need to move or analyze, the scale of documents that we have available. And that's where a lot of these Gen AI apps and systems are working. It's a floor, right? That is where you can make high adoption numbers. But if you look at the numbers, they're not that impactful. And you're like, if you think about a local business that sets up a website without a developer, probably they get 10% more customers and 10% more revenue. But if you think about those high value efforts that cannot be easily directly replaced by Gen AI or assistants, those are tasks that need a human in the loop, that need control of the development cycle. That is where we want to be. We want to be in those spaces or where we really operate as research software engineers or scientific computing folks. Those are the high value, high impact efforts that move the needle when it comes to impact, that move the needle in your area of expertise. And it's not surprise that now reports are coming out saying, yes, these floor applications have very high adoption, but low transformation and low return, because experimentation for the sake of automating or commoditizing tasks at a frequent, already known and explored task at a different scale is never going to move the needle as novel research. If we look at the tooling instead of the applications, or if we think about research development or research software development, then the floor goes again as this Gen AI applications, right? This is just a user-facing tooling. It never goes back to the platforms or the tools or the infrastructure or the science that makes all of that possible. Then somewhere in between is how you start interacting and start customizing, for example, models, if that's what you're into. But start thinking into frameworks and eventually where the most impact, where the ceiling is actually being pushed is at a foundational level. All those research tools, all the scientific computing, all of those foundational platforms that make everything happen. And that, of course, includes everything open research and research software. So when we're thinking about how to deliver impact, we want to move from a desire of adoption to development and maintenance. And that sounds boring, I know. But this is the truth. High value use cases and impactful use cases are worth that development and maintenance effort. That's what's going to set us apart and keep research software relevant from this floor, from things that can only be customized to provide a better UX experience or a product, or making a chat interface nicer, or add another commoditized capability. focusing on that development process and into keeping the research software engineer in the loop is what allows us as researchers, as research software engineers, as open source developers, however you want to identify yourself, to focus on this high value stuff, find opportunities for innovation and creativity, and find opportunities to move the needle. So if we were to ask ourselves, will AI replace us? No, not really. Because we don't want to operate, and we don't operate at that floor level. We don't want to keep pushing that floor up. Right? We're pushing the ceiling. That's our goal. And this is also where we shine as research software engineers, identifying these opportunities and pushing the boundaries. That's where we are. Now, maintenance work, because I said development and maintenance are worth, they're worth those maintenance and development effort. Maintenance translates to long-term impact. So it moves our mindset and our work cycles from purely adoption to thinking in terms of platform. And that's really when you start spending time in maintenance is where you make significant gains in terms of usability, accessibility, resiliency, availability, and sovereignty. And it's again, a balancing act. How much development time versus maintenance time you're going to spend in a project or in a tool or in a platform really depends on what you're building, who you're building it for, and how long it's been around. And so like these days, if I think about one of the projects that I work on, let's say Conda Forge, we spend way less time on development and a whole lot more time on maintenance. And it becomes very, very hard then, like it's a complete different approach to keep that community alive and bring in new people and deliver value. Because we have now 10, 15 years of innovation, development, and technical debt that we are dealing with on a daily basis. So really, when I'm talking about maintenance, I'm not talking about just code. Because open source software and research software, like long-term research software, is not just code. It's a socio-technical system. And that's what makes sustainability so hard. Because we cannot just throw money. Let's say if all of a sudden, all of these companies and we just got that 10% of that $8 trillion value, and we just throw it at open source or throw it at research software, that wouldn't solve our sustainability issues. Because we really need to look at it from a socio-technical ecosystem point of view. Yes, we have the tooling, we have the technology, that's where tool and infrastructure fall into. That's a very critical part. That's usually why a lot of people come to research software or open source, because they need a tool to do something. They need a tool to achieve another goal. But we need people, right? We need people thinking about this technology. We need people advocating for these research processes, for these workflows, for this tooling, for this infrastructure. We need people who care enough about them to spend time on making them better, more resilient, more secure. And as soon as you have people, you have to start thinking about culture, right? How these people are going to interact with each other. What our shared values and goals are, how we are going to interact with other circles and other parts of the ecosystem that are adjacent to us. And that means processes, right? That means we have to start thinking about how we make decisions. If we get funding, if we get money, where does that money go to? Development or maintenance? How do we decide who gets paid to do what? Are we going to continue to focus on raising the floor or raising the ceiling? And sure, if we get money, we have to somehow demonstrate where that money went, right? Most of the time. So you need goals and metrics. Again, what is my metric? Am I interested in knowing how many people use my tool every year? Or am I interested in other fussier, more complex metrics? How is my tool advancing research? What does this mean in terms of academic or innovation or research excellence? So the reality is we need a full systemic change. We need funding, again, and incentives and mechanisms that support and prioritize sustainability from this point of view. A very holistic sustainability picture, and not just the tooling, not just the tooling for today. And again, this is where us as research software engineers shine. Again, whatever your jam is, whatever your hat is, and whatever it is that you advocate for, if we think about that, we think about open software, open research, open science, open protocols, open data. Right? Everything has the word open derived from the openness as a principle. And that doesn't mean it's licensed. It doesn't say, oh, this is licensed, we're distant tenants. And if you meet distant tenants, that makes your software research, blah, 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 open. Openness is a strategic decision. It's a strategy for resilience and impact. And in this age where AI is everywhere, where the highlights and the money is following where money is already going anyway, it's a good way for us to remember that transparency builds trust. And trust leads to collaboration, helps us raise the ceiling. It ensures that we and our tooling and our platforms and our work stays relevant. So if you, in any way or capacity, are thinking, how can I make my software or my platform relevant for tomorrow? Let's aim to focus on raising the ceiling and not the floor. Find ways to balance innovation and maintenance. Push for cultural change, as hard as it is, as slow as it is, as demotivating as it can be. And invest in people, in your community, in governance, in setting those processes on how you're going to make decisions early on. And champion openness as a core principle. Because open source and top-notch research do not run on a secret sauce. Secret sauce might give a company a monopoly, might lead to the impression that big tech is reinventing the wheel and reinventing the path, and that's fine. They can do that. But knowledge in open source, in open research, in open areas, knowledge gets shared and built upon. And that is how we keep research and software relevant. This is how we built this small community and ecosystem for ourselves. And this is how we're going to keep it alive for years to come. Thank you.
Tania, so now we have time for a few questions. So let's start with the first one. What advice would you give to an organization that has chosen to invest in maintenance to help them choose what open source software platform initiative that they should invest their effort in?
Oh, this is a good one. It's pretty tricky. And this is the kind of questions I love. First, identify the critical tooling and infrastructure for your organization, for your company. Take stock of what you're using throughout, like, especially in your high impact areas. And make a mental exercise of what would happen if that is, for example, Honda or Jupyter or Python or Fortran or R, whatever. What would happen if that tool were to disappear? Or if the one maintainer were to win the lottery? How much would that cost me to take over that or rebuild everything and maintain it from scratch? That's a good way to identify where you should first make that investment. And second, talk to those communities. Talk to the maintainers, talk to the people doing the groundwork and understand what they need, how you can better support them and work with them to get them there. That's how you're going to stretch that commitment and that investment way longer, way further than just dropping in a couple of $1,000 or dollars or hopefully many thousands of bucks from there.
All right. The second one is somehow related, I think. On the part of funding and incentives to invest in maintenance works, how should we best frame this to funders? What have you seen to attract funding right now?
Oh,
do you have a magic?
No, I don't have a magic trick. Again, it depends. Sometimes it depends on the funder. Again, understanding what they care about. It's like any grant. Understanding what they care about, how you can work with them. There is so very little funders that are actually giving money towards maintenance. And that makes it very hard, because that means every single project that is under-resourced and under-maintained and understaffed is going for that money. And so what really, we should be doing is trying to convince other funders to also chip in and fund this maintenance and sustainability work.
Right, let's take a last one. Have scientific Python projects experienced influx of AI-generated contribution? If so, how is the community responding to that?
Badly. I hate that, right? Absolutely, I hate that, because that is a prime example for a pushing the floor application. Like projects where we are already a few maintainers, we get so many issues, so many pull requests, we have to deal with tech debt. Now we're seeing an influx of AI-generated issues with no context, an influx of AI-generated PRs without context, and that requires time and effort. I mean, from a group of people that are already struggling, from people that are already burning out. It just makes our lives harder. So I've seen open source projects adopting policies and saying, well, if we catch wind that this is Gen AI or AI generated, we just close it right away. No explanation, nothing. I've tried to explain to people like why this is a bad idea. Like not the policy, but or the process, like people adding this tooling, but it's very hard, right? Because they have metrics, they don't. They have to push the AI products, but badly. We're like honestly, we're dealing very badly with them. I don't think anyone is happy about getting all of a sudden hundreds of issues. I'm sorry.
All right, let's thank Tania again